Hello everyone, welcome back to another kinetic tutoring episode. Today we're taking a look at improper integrals and how to solve them. Let's get straight into it. Here we have the integral from 1.3 to infinity of e to the negative 2x dx. So let's get straight into it. First thing we're gonna want to do is set the limit as t approaches infinity of the integral 1.3 to t e to the negative 2x dx. All we did was just make this infinity t. Alright, so here we have that, and from here we can evaluate using u sub. U equals negative 2x, du equals negative 2 dx. There we have that. So then our answer for the integral will be negative 1/2 e to the negative 2x, and we're evaluating it from 1.3 to t. So now let's evaluate it. I'm going to bring the e to the bottom to the denominator so that the coefficient becomes positive. You get negative 1 over 2 e to the 2x, and when you evaluate it from 1.3 to t, you get 1 over negative 1 over 2e to the 2t plus, because it's two negatives, a double negative, plus 1 over 2e to the 2 times 1.3, which is 2.6. There you have that. Now you plug in your infinity. 2t is just going to be 2 times infinity, which is infinity. E to the infinity is also going to be infinity. 2 times infinity is going to be infinity once again. And 1 over infinity, negative 1 over infinity, is going to be 0. So we'll have 0 plus 1 over 2e to the 2.6. So that will be your final answer. There you go. That's how you go about solving that problem. So we can say that this integral is convergent, meaning it converges to a value instead of going off to infinity or negative infinity. So yeah, let's take a look at another example. Alright, so we're going to do the same thing here, except the t is going to be negative, going to negative infinity. We're going to have integral t 5 1 over x squared plus 1 dx. And this equation right here is the arctan equation, so we can just evaluate that integral really easy. We just know that that's the formula for arctan. So we have arctan x evaluated from t to 5. Alright, so now let's take a look. We have arctan of 5 minus arctan of t. So that'll be arctan of 5 minus arctan negative infinity. So let's take a look at the arctan graph. I'm going to draw a rough sketch of it. Alright, so here's what that looks like. And we're going to have two horizontal asymptotes. The top one being at pi over 2, and the bottom one being at negative pi over 2. And so as we see that as arctan approaches negative infinity, the y value approaches negative pi over 2. So the limit as arctan goes to negative infinity is negative pi over 2. but the two negatives cancel out, so you get arctan of 5 plus pi over 2. There you go. So this one converges as well to this value right here. All right, let's go to the third problem that I have set up. Here it is. And this is the same thing as the first time. Limit as t approaches infinity. And then we get integral 6 x plus 4 dx. So the first thing I like to do is to take out this 6 for the sake of simplicity. So we can take that out of the integral. Sorry, I meant to put a t here. There you go. 1 over 6 plus 4 to the power of 3/2. And then from here we can do a u sub. U equals x plus 4 du equals dx. So then we get 2t 6 1 over u to the 3/2 du. And this is just u to the negative 3/2. And when we do this integral, what do we get? We have to add 1, which gets us negative 1/2, and then we have to divide, so that gives us negative 2. So negative 2u to the negative 1/2 is the answer for the integral, and when we put it in terms of x, we will get, because u is x plus 4, I'm going to put this on the denominator to make that positive. You get negative 2 over the square root of x plus 4. There we go. And now we evaluate this from 2 to t. All right, so negative 2 over square root of t plus 4 plus 2 over square root of 6. So there we have that. T is infinity, t plus 4 is infinity, square root of infinity is going to be infinity, and negative 2 over infinity is going to be 0. So our final answer will be 2 root 6. Alright guys, that's all I have for you. These are 3 example problems that hopefully help you figure out these type of problems. If there's any questions, leave them down in the comments below, and I'll see you guys next time.